You know that old phrase, back to the drawing board? That's what you don't want to have happen to you. You do not want to go through the process of writing down, right, all the things. Here's my network, and here's going to be my access points, and then here's going to be my wireless LAN controllers. And so you've got the physical topology of the access points, the layer 2 and layer 3 topology of the wireless LAN controllers. You got it all figured out, and then you find that it can't support the traffic that you need, or that there are bottlenecks. So, or that clients are not roaming the way that you thought that they would. So, what we want to do, gang, is we want to make sure that we are designing these according to best practices based upon the size and scale and goals that you have in your network. So, there's two goals that you may have, and they're not either or, it's one and or the other. The two key goals that you might have would be seamless roaming, right? So, again, my clients that I have in my network being able to connect to various different access points associated with one or more controllers. Put those out there. And so I want to be able to have my devices do what? Just roam seamlessly across this network and never lose access. So that's been our goal so far. That's called seamless roaming. There's also the idea of nomadic roaming. Wireless LAN connectivity provided when needed. So constantly needed versus on demand. Typically, I think of my seamless roaming being primarily layer 2 roaming, whereas my nomadic roaming is more like layer 3 roaming, where I want support for roaming between buildings that, again, we don't want to do this all the time. We don't need to have nomadic roaming isn't supported by, let's say, a switch peer group, but instead might be managed by multiple groups and roaming between different groups as necessary. So those are our goals, and we recognize sometimes we need seamless roaming, sometimes we just need to support nomadic roaming. It doesn't all have to be nearly instantaneous, right? So if that's the case, then the question becomes, what is the supported capacity of any particular design? And then there's what's the recommended capacity. Just because you can potentially support 4,000 access points doesn't mean that it's going to work well if you do that without maybe some other contingencies in place. So keep that in mind. Supported capacity does not necessarily equal the recommended capacity for any design layout.